Hi, in this video I'll be covering part 2 of alkanes basically. So I will be, I think, finishing topic 4 in this video, hopefully. So let's just start. So we're going to discuss alternative fuels and their importance. And to discuss that, we need to first of all appreciate the, major problems of using fossil fuels, and that's why we need the alternative fuels. So the major problems are basically the carbon dioxide emission and the fact that fossil fuels are finite. They will basically run out. Okay, so the problem with carbon dioxide emission is that carbon dioxide is a greenhouse gas and it absorbs the reflected infrared rays from the Earth's surface. Okay, so basically, the sun gives us all the electromagnetic waves. That becomes energy from photosynthesis and etc. And some of that has to be reflected back into space, and that is done with infrared rays. But the greenhouse gases inside our atmosphere, they're going to absorb that reflected rays, and that is going to increase the global atmospheric temperature at the surface of the Earth, and that is going to accelerate global warming and obviously cause climate change. Okay. And yeah, the finite resource, it means that it's non-renewable, right? So it's not sustainable, right? Yeah, unsustainable. So we're looking into infinite, basically, renewable resources that can be used as fuels, okay? So that can also reduce carbon dioxide emissions as well, okay? So we're trying to look for the sustainable alternative fuels. So we have the first example, bioethanol. Okay, so this is the equation for the complete combustion of bioethanol, just ethanol basically. And burning ethanol as fuel does release some carbon dioxide gas. However, ethanol is obtained by fermenting plant materials. Okay, so the raw materials over here is plants primarily, and therefore we must grow plants. And while plants grow, they absorb carbon dioxide in the atmosphere to photosynthesize. And so with this in mind, we may describe bioethanol as a carbon neutral fuel. Carbon neutrality basically means that the net carbon dioxide emission is zero. So carbon dioxide produced is equal to the carbon dioxide absorbed or used. Okay, so but producing fertilizers for growing plants and transporting the raw materials, basically, if you have ethanol being produced, you have to put that into the power station. These add to the carbon emission. Transporting materials, we need to use cars, we need to use ships. So that is going to add to the carbon emission. Okay. So it isn't perfectly carbon neutral, although it may reduce emission, okay? Some other drawbacks of bioethanol includes that the fermentation is a very slow process. It uses yeast, it uses other enzymes, and their optimum temperature is only like 30 to 50, less than 50 degrees. That's a very low temperature. Kinetic energy is very low. It's a slow process. And ethanol must be purified from the mixture of plant materials and enzymes and other things that we need to put into the reaction mixture, okay? That gives a relatively low percentage yield because the purification steps might be, complex. And for the second example, we have hydrogen as our alternative fuel. So that is the equation for combusting hydrogen, burning hydrogen in air and oxygen. So hydrogen readily reacts with oxygen to produce water as the only product. If it's the only product, obviously, the net carbon dioxide emission would equal to zero. And therefore, can we describe hydrogen as a carbon neutral fuel? Not really, because hydrogen, first of all, is largely obtained from natural gas, and in the production process, some carbon dioxide is released, okay? And also transportation of the materials, again, it releases carbon dioxide. And yeah, also the fact that natural gas is from crude oil, a finite resource, it makes it a little bit less sustainable. Okay, so if we look at other ways to produce hydrogen in a renewable way, first of all, we use solar power or wind energy or geothermal energy, and etc., generating electricity. Okay, and we're going to basically use this electricity to electrolyze, separate water into hydrogen and oxygen, using electrolysis. Okay, so electrolysis, electro means we're using electricity, lysis means to break. Okay, so we're breaking water into hydrogen and oxygen to obtain hydrogen. Okay, but this is only around 5% as of 2020, I think, or 2019. 5% of hydrogen produced to use as fuels. Okay, so that's not a very large amount. Okay, 95% comes from natural gas, a finite resource. Okay, so if we could expand the electrolysis process using the renewable sources of electricity, this would be a sustainable option as an alternative fuel. Okay, and now that's basically it for renewable alternative fuels and discussing carbon neutralities. Okay, there was also petrol mentioned in the syllabus. I'm not sure why petrol is in there, because it's just crude oil. If you combust crude oil, you get a lot of carbon dioxide and water, and you can get carbon monoxide from incomplete combustion. You can get nitrous oxides, sulfur oxides. Those were discussed in the last video, so you can find that information in the last video. Free radical substitution. Now, we need to look at some mechanisms. Curly arrows. We've seen homolytic fission before, so that's going to be in this topic. So this is a reaction between alkanes and halogens, okay, with the presence of UV rays. So free radical substitution, first of all, we need to have initiation, and then as a second step is propagation, and then the last step is called termination. Okay, so we will look at all these individual steps. So and just to remind you, free radicals are species with an unpaired electron. Okay, so the example that I'm going to go through is just the simple example of methane reacting with chlorine. Okay, so just to remind you that, alkanes, they're very unreactive substances. So this is why we need free radicals, which are very, very unstable, that attacks these stable molecules. Okay, so let's look at initiation. Initiation is basically forming free radicals via homolytic bond fission using UV light. Okay, so yeah, free radicals, homolytic bond fission, UV light, these are very important words. Okay, so remember, yeah, UV light is also, you can just say sunlight, because sunlight kind of, it has all the waves of the electromagnetic spectrum, so obviously it has UV light. And when UV light basically hits my chlorine molecule, it's going to break that bond like this. Do you remember what half arrows represent? It represents only one electron moving. Okay, it's not a full arrow like that. Yeah, so it's just a half arrow, so it's only one electron moving from the bond to each of the atoms bonded together. Okay, so we have one electron going to this chlorine, and one electron going to this chlorine, making two chlorine free radicals. Okay, so you can also write the equation like that. So the above, it would be called a curly arrow mechanism. Okay, when they ask you to draw a curly arrow mechanism, you need to draw something like this. If they ask you to write the equation, you should write something like the one shown on the bottom. Okay, so all right, yeah, and then we have propagation. the second step of free radical substitution. So free radicals react with alkanes to form a different free radical and also with a different stable product. Okay, so let's look at what's happening. The chlorine free radical is attacking my methane molecule, and HCl has formed, and I formed a methyl free radical. So I can just simplify that into that. I just wanted to show you that the unpaired electron belongs to carbon, not hydrogen. Okay, although when you write it in a simplified form, the dot is, you know, after hydrogen, it's on the carbon. Okay. And we have the methyl free radical again attacking a stable molecule, chlorine, and the, you know, if we have more chlorine present, then we're going to regenerate chlorine free radical, and I'm going to get a chloromethane. Okay. Yeah, just notice that I have regenerated my chlorine free radical. Okay, my last step is termination, where two free radicals join to give stable molecules. Okay, so I had two different free radicals, which was the chlorine free radical and the methyl free radical. So, which means that we can have two chlorine free radicals joining together to make a chlorine molecule, which is stable, and also we could have two methyl free radicals joining together to make an ethane molecule, and also we could have a methyl free radical and a chlorine free radical joining again to make a chloromethane. So yeah, these are the products that can form from termination. Okay, so to summarize, we have the initiation step over here, just one step, and using UV, and we have two steps of propagation, and we have three options for termination reactions. Okay, so yeah. This is just the summary, and just wanted to mention that we don't use free radical substitution very often in practice. Okay, so in the syllabus it says explain why free radical substitution has limited use in synthesis. So synthesis in terms of organic products when we're trying to form halogenyl alkanes. Okay. So this is because if free radicals like chlorine, the chlorine dot, the free radical, they are still present after we have formed our desired product, like chloromethane, if that was our desired product, it can still attack our desired product, so the chlorine free radical attacking our chloromethane that has formed, and give different compounds. Okay, so let's see what's happening over here. The chlorine free radical is now attacking my chloromethane, the one that I want. Okay, meaning that it's going to knock out another hydrogen and form hydrogen chloride, HCl, and then that new free radical is going to go and attack my stable chlorine in excess. You know, if I had more chlorine, then it's going to give me a dichloromethane. Okay, so which I don't want. Okay, this is a product of further substitution. So these reactions are called further substitution. Okay, so as long as you still have chlorine free radicals, if you don't get rid of them, this is going to happen again and again. Okay, so that dichloromethane is going to undergo propagation again and form a trichloromethane. A trichloromethane can again, you know, undergo propagation and give a tetrachloromethane. Okay, and dichloromethane, trichloromethane, tetrachloromethane, these are all unwanted products. Okay, I wanted just, you know, one chlorine substituted. Okay, just chloromethane, but all these three products can just be produced by further substitution. Okay, meaning that the atom economy can be lowered by a lot. Okay, so because, you know, atom economy is desired product over all products that formed, right? So the fraction is going to get very small. So yeah, that is the reason why we don't use free radical substitution in terms of, you know, trying to get halogenyl alkanes. There are different methods like substitution of alcohols that has a higher atom economy, or electrophilic addition of alkenes, which I will go through in the next video, I think. So yeah, stay tuned for the next video on alkenes, which is topic 5. And yeah, I hope this video helped. If you have any other questions, just leave a comment below. And yeah, again, see you in the next video. Bye.